This body has been off of that chassis for way too long. I think it's time we reunite the two so it can stop taking up 2 spaces in my garage. I already know there's going to be a couple issues with trying to do this though. First off, this shifter doesn't quite work. I've got 4 low, neutral, 2-wheel drive, but I can't quite get this all the way to 4-wheel drive. So that's the first problem with this shifter. Second of all, this shifter runs into the drive shaft. There's not enough room here for the shifter and the drive shaft. They're occupying the same space. So before I put the body on, I'm gonna fix this shifter because it's gonna be way easier to do now than when the whole thing's back together. I could just buy the correct shifter for this transfer case, but I've already got this one and I don't think it's gonna take that much to modify, so I'm just gonna modify this one. What I need to do is find a way to make this shift gate longer so that I can actually put it into 4 high, and then I need to bend this bracket. So let's get to work. Alright, so I welded on a couple new brackets onto this shift lever. The first one just extends this shift gate so that I can get all the way to the shift. And then I added an additional bracket here just to brace it, to make sure it's not too floppy and isn't going to have any issues. And it's got a nice cutout in it so that the shift fork can rest in there fully. I need to bend this so that I have clearance, and I also need to look into making another one of these shift gate plastic pieces. The shifter no longer hits the drive shaft. You can see there's quite a lot of clearance now. I shouldn't have to worry about that. To finish off this shifter, I need a new one of these. This is the little bushing that when you're moving the shifter back and forth, it runs into this plastic thing so you're not just banging the shifter into the metal the whole time. I need one of these, but with this shift gate being much longer. So I need to figure out a way to make one. And if you've been paying attention, you might have seen that sitting behind me in some of my videos. This isn't just a desk ornament, it's also a 3D printer. And to do weird shapes like this will be the perfect tool to make it. Now, a couple quick things about 3D printers. First of all, the material that this is using is either a PLA or an ABS. This is really good for prototyping. It's really good for figuring out what shape I want the final part to be and to test it out and make it all fit. But the final part that comes out of this is going to be made of PLA, and it's probably going to fall apart. In my opinion, a 3D printer like this is really good for making sure that you can get all your dimensions, so you can prototype parts, and so you can make sure your designs work. They're not all that good for finished products unless the product is purely cosmetic, like say a bezel for a screen or a gauge or something. However, you can fix that. Once you've prototyped the part and you make sure it works, then you could take your models or even take the part you printed and take it to your local machine shop and say, hey, now I want this part in Delrin or some other actual engineering plastic that'll stand up to the abuse. For my purposes right now, I'm going to print it in PLA and see if it works. And if it doesn't work, then I'll either get it machined, or even better, I can go online and find somebody who has an SLA printer which can print in thermosets and have them 3D print me the part. I might do a full video on 3D printers at some point because I do think they can be a useful tool for the shop, but you do have to manage your expectations as to what you're going to get out of these. So here's my part in CAD. I did it in SolidWorks. I wouldn't recommend SolidWorks because it's really expensive, but I would recommend something like Fusion 360, which is a fully kitted out CAD suite for free for hobbyists, which is an amazing deal. So if you're wanting to get into CAD, that's what I would recommend is Fusion 360. I don't use it because I have so many hours in SolidWorks that it's just much quicker for me to do it this way. And one of the perks of having to work from home during a pandemic is you get to have nice engineering software on your computer. So this is the model. You can see I have these little clips on the back. Little clips like this complicate a part by a huge degree. For example, because those clips are there, this would be a very hard part to machine, which means if your end goal is getting it machined, you might want to reconsider the way it mounts. Personally, I'd recommend just putting some holes in it and riveting it to the thing rather than trying to use clips. And the other issue is that you have to account for how rigid the plastic is and everything to make sure these clips have holding power and that they don't fall apart. This is the part in SolidWorks. However, the 3D printer doesn't understand 3D models per se. First thing you have to do is you have to make it into a mesh, which is you tell it where all your vertices and lines are, not exactly the shape of the model, and then it can understand that. Here it is in what's called the slicer. This is what takes the 3D model and turns it into machine instructions for the 3D printer so that it can understand what it needs to do in order to make this part. The way the 3D printer works is it adds one layer at a time. So it'll start out here, this is the nozzle of the 3D printer, and it will draw out each individual layer one at a time, just drawing out every single line in liquid plastic. And then as it draws out every line, it adds a new layer and a new layer until you get your finished part. Turned out all right. For some reason, the 4 is missing on the 4 low and the 4 high, but I'm just gonna have to paint it on or something or just leave it, it's fine. You can see the difference between the old one and new one. It's kind of a lot. All right, back in the garage, and here's this piece. Now, I've already noticed there's a couple issues with it. Like, for example, because of the way I welded on this bracket, there's a little step in the bracket. So I should have put a step in this bushing, but I didn't, so that'll have to come in V2. Clips in good. All I need to do is reprint this, make this slot just a hair longer, and cut out that section there. This is why 3D printing is really good for prototyping, is because you notice small issues like that, and then you can correct them easily, and then spend 50 cents on plastic, fix the issue, and then you know in the end that you have a design that will work properly. What was this video supposed to be about again? Oh yeah, the body. Let's start putting the body on. All right, I got the chassis as low as I can. The front, I got the flat tires on. The rear, I've got my shortest set of jack stands underneath it. The trick is going to be getting the body high enough to actually clear the rear, so let's see if we're able to. All right, YouTube, let's give you an update of where we're at. As you can see, we're close, but this still needs to go down about 4 inches. And unfortunately, the transfer case is running into the transmission tunnel. So I am gonna have to start cutting out the floor where the transfer case is to add some clearance to get the body all the way on. That's okay. I figured I'd probably have to do some cutting on the floor anyways, so let's get to it. As I've shown a couple times, it's possible to take a body off and put it on in your garage with a cherry picker. If you care about your body, I wouldn't recommend doing this, because I did end up scratching up the skirt there, and I did end up bending this guy down here and a couple things like that, but this is an off-road vehicle. I'm not too worried about some dents and scratches, But just thought I'd let you know, if you care about your body, maybe don't do it this way. All right, I got the seats out, got the center console out. I didn't show me doing that because honestly, I hate doing work like this, so I can't imagine you guys would want to watch it. It's basically just pulling out huge stacks of bolts and screws and clips, and you never know where any of them are at, and it's fishing around, and yeah. Got the carpet pulled up. This is what it looks like. It's time to cut some metal out of this tunnel right here so that the transfer case actually fits. The body is on. She fits. That is a Cummins and a Ford Explorer. Got the front body bolts all bolted up. And I was able to do it with only 1 inch of body lift. Now, before I show you the interior, so that you see what I had to do to make this work, let me remind you that the first thing I ever did in this series was cut off the whole front end, so I'm not exactly afraid of doing damage to this body or anything. Take a look at what it took. An added bonus of this is that I can service the transmission and transfer case while I'm sitting in the driver's seat. I cut out a bunch of sheet metal here, and what I'm going to end up doing is I'm going to end up fabricating a new transmission tunnel to cover up most of this. This is how it turned out, lots of cutting. Now, granted, I probably could have gotten away with doing a lot less cutting if I just added a couple more inches of body lift, but I wanted to keep the center of gravity of this vehicle low as reasonably possible, and it's an off-road vehicle. I don't mind having to cut into it. Other than having to move the front end forward, this is the biggest modification I had to make to the Explorer itself to make the Cummins actually physically fit. There it is. I will fabricate a transmission tunnel to replace what I cut out, but that's going to be in a future video. For now, I was able to get the body on. The Cummins is officially in the Explorer, and that's what I wanted to do. So thanks for watching this video. Like and subscribe and stick around if you want to see the next one, and thank you for watching.